Hi, welcome to Kruskal's algorithm example using Java. Here we want to establish the minimum spanning tree from given graph. So this is the graph. So for this graph we have to pass the vertex, source vertex, destination vertex and weight. So here in the main method we are defining number of vertices are 4 and number of edges are 5, and we are going to call the graph class with the number of vertices and edges. So here we are passing the source vertex 0, right? So destination vertex 1, and for the respective weight 0 to 1, so 0 to 1 is 10. So we have written 0 to 1 is 10, like that. Source vertex is here the edge number, this is the edge number in the array. So already 0th edge we have given, now we are giving the first edge. So first edge source vertex is 0, then destination vertex is 2, then weight is 6. So like that you have to keep on give the edge cost to all the vertices which are connecting by respective edges. Then we are calling the method minimum spanning tree. So here before going to the minimum spanning tree, here we are having the graph class. So the graph class is defining the class edge which is implementing the comparison of two edges to select the minimum edge. So here to select the minimum edge we are passing source vertex, destination vertex and respective edge weight. Then we are checking the current weight and minus with the comparable with another edge weight. So whichever is minimum, that will be used for shorting, right? So now here we will call the Kruskal method, minimum spanning tree method. Here we are creating one array which is to store the minimum spanning tree with the number of vertices v. Then just we are initializing some variables for future purpose. Here we are creating the number of edges by that will be stored in the variable result. So here as of now we are having the 5 edges, v number of edges. You look at this. So here we are having the 4 vertices. Then here we are going to create the number of edges that should not form the cycle for minimum spanning tree. So that should be e equal to cardinality of v minus 1. So that's what we have given here, less than v. Then we have to short the given edges. So here the edge cost is this one we have got from the graph. So that is shorted it based upon the ascending order. Then here we are going to allocate the memory space for v number of subsets. Here initially all the nodes, suppose I am having the 0 vertex, 1 vertex, 2, 3. So all the vertex will be treated as single tree in the forest, single tree in the forest as per the Kruskal's algorithm. So based upon that single tree, so this is the Kruskal algorithm. So here we will create the forest from the set of vertices in the graph. Initially we are assuming each vertex is a separate tree. Then we will short out all the edges into the low weight to high weight, that means ascending order. Then only we will select the minimum edge one by one from this shorted edges. So as per that, in this location we are creating v number of subsets, individual vertices. All the vertices are assumed as a single trees. So we are creating the v number of subsets. So just it is having the subset of vertices with vertices number 0, 1, 2, 3. Right now we are going to create the subsets, v number of subsets with the single element. So the node 0, which is the no, for node 0 parent is also node 0 because only single tree, right? Each node is assumed as a single tree. Rank is 0 initially. Then for node incrementing by 1, the node 1, okay, for node 1 which is parent is same node, rank is 0 for node 2, then value is 2, but the rank is 0. The node 3 parent is also node 3, here rank is 0. So the here the each node is acting as a parent itself, okay, to itself. Then now we are going to pick the next edge, okay. So that edge, here number of edges should be less than number of vertices minus 1, then only it will not form the cycle, okay. So here we are going to select the edge, the next edge, right. So the edge is minimum edge, it is sorted out already. You look at this, it is sorted out. So from that we are going to select the minimum edge. So here the minimum edge is here 4, you look at that. So the minimum weight edge is here 4. So the minimum weight edge is selected. For that, source vertex is here 3 and 2, and destination vertex is 3. We are taking in that manner. So 2 and 3 we are calling here for the subset next edge is dot source is 2. So here the find method is taking the subsets for four vertices. Here subsets, here for each this subsets, here it is 1, okay, because this subset, you look at this, for this subset this is having only one node for each subset, okay. So now only one node integer, here source is passing 2. Now we are checking subsets of 2, subsets of 2 dot parent not equal to 2, but it is false, because here for 2, for 2 the 2 itself acting as a parent. So this is false. If it is false, it will return subsets of 2 is parent, so that is the parent, okay. So now here uh, here we are passing that 2 is assigned to the x. Y, again for y also, here we are passing subset, here is 1, here 3, here is the destination. When you are passing this, again it will do here 1, here it is 3. So here it is checking, right, subset of 3 dot parent not equal to 3, right, which is false. So it will come here subset of 3 dot parent is same thing. So here this is the parent. So now x not equal to y, okay. So x not equal to y, here this is true, okay. X not equal to y, x is the 2, y equal to 3. So this is true. If it is true, the resultant of e, so edge is incremented by 1. So now we are going to add that edge value 4 into the minimum spanning tree. So result is the variable which is storing the minimum spanning tree. So this edge between the 2 and 3, which is having the value 4, going to add in the minimum spanning tree. Then we are making the union of this subsets comma x comma y. So now this x comma y 2 and 3 is going to be added into the subsets, okay. So then if that edge is not available, I mean this condition is for, suppose 2 to 2, if it is like this, say forming the cycle, then it will be discarded. So based upon that, next you can select next edge, next minimum edge. Then again you have to follow the same procedure. So based upon that, you can add into the minimum spanning tree. So here the union, in the sense, we will make the subsets comma x. So we will find which is the parent, which is the child. So here the subsets is initially this is 1, this is here for this 2. So we will use that. So it is the, here x root is here 2, x y root is here 3. Then here we are checking x root rank. Here rank is, for both rank is 0, here this is also 0. If it is not root, which is false, so x root is assigned to the for y root x is the parent, okay. So for 3, you look at that, this is y root is here 3, okay. So for 3, 2 is the parent, okay. You look at that, when you are looking this graph, right, here when you are looking this, the 2 is the parent for 3, right, that's what given here. 2 is the parent for 3, right. Then we are increasing the rank for the 2 by 1. So already rank for the 3 is 0. You look at here. So now the rank for the 3 is incremented by 1. So for the 3, sorry, for the 2, for the 2, rank for the 2 is incremented by 1. So which is a parent to 3. So this is the edge we have selected with weight 4. So here this is the procedure to assign the rank one by one when you are adding the minimum, I mean edges into the minimum spanning tree. Then next edge will be selected here. Next minimum edge is here 5. So it is having the source vertex. Again you look at that. Here the next edge is selected. Here the again it is going back. Okay, so from this it is going back. So now it is selecting the next edge. So next edge is here 5. Okay, 5. So next edge is here 5. So for 5, source vertex and destination vertex, source vertex is 0, then destination vertex is 3. So for 0 again you will call the find. You look at this. So here you will call the find subsets 0. I sorry, subset is here. Now we are having 2. Okay, 2 vertices are available in the subsets. Then value is here 0, right? So now we are checking subsets of this value is 0. Okay, subsets of 0 dot parent not equal to I. What is the I? 0, which is false. Then subsets of the 0 itself acting as a parent. So now for 3, okay, 0 to 3, okay, we are passing this one. So for here 0 subsets is we are having 2, 3. So now we are checking subset of parent 3. Okay, subset of parent 3 dot parent. 3 dot parent is here not equal to I. Yes, it is true, because for the 3 parent is 2. Parent is 2. So we have to identify the parent. So for the parent is 2. Okay, so now the subset of I dot parent is here 2. So 2 is assigned to subsets of I dot parent. Then we are returning the value 2 here. So 2 is returning here. So now for this here the value y is here 2. Okay, value to I is here 2. So now we are checking x not equal to y. Yes, you look at that, x is not equal to y. So here 0, here y. So then resultant edges. So edge is here 5, which is added. So now we are adding the x comma subsets. So 0 comma 2. So now we are adding that 0 comma 2. So we are adding that edge, right? This edge, right? So 0 comma 2, right? So like that you have to add union of x comma y. Again you will add that 0 comma 2, right? So here uh, here we can add this edges one by one like this if it is not forming the cycle. So finally we will get the minimum spanning tree like this, 0 to 3, here 2 to 3, here 0 to 1. Total cost is 19. You look at that, 4 plus 5, 4 plus 5 plus 10, we are getting 19. Thanks for watching.